we are now recording. We are still working on, look at our goal. What are we doing when we're done with this section? You will write prime factorizations of a number, okay? So we start off. The base of my tree has 48 on it, okay? The base is 48. Are you wanting just to be there all the time now?
Yeah.
Okay? Next time, rather than you making that decision, come to me and just let me know, okay? But I'm fine with it, okay? All right, so looking at rules of divisibility, what's the first number we're going to check on to see if it's going to go? Macy?
24.
2 times 24. So I look at the 2 first. Is 2 a prime number?
Yes.
Circle it up. It's a prime piece of fruit there. Okay? Now, I have to look at 24, the branch that has 24 on it. It's not prime, so it can't produce any fruit yet. I want specific types of fruit. Now, I'm going to go back to my rules of divisibility. Is it an even number?
Yes.
So what does that tell you, Callie? If it's an even number, it's divisible by what? 2, okay? So I'm going to take 2. I got a piece of fruit there. Well, what's 24 divided by 2? What's it going to be, Jesse?
12.
12. Is 12 a prime number?
No.
Nope, it sure is not. And so since it's not prime, I got to bring another branch down. Okay? What's 12 divisible by? The first prime number you can think of for the number 12. 2, because it is also an even number. And 2 times what is 12?
6.
Is 6 prime? Nope. So I've got to bring another branch down. And if I take another branch and I bring another branch down, I got to move this over a little bit. What number is going to go into 6? And I'm looking for my primes. So the first prime that you think of that's going to go into the number 6, David, what's it going to be? 2. And 2 times
3.
Is 3 a prime number?
No. Yes.
Yes, it is. So now, have I listed all the primes? Have I factored them out? I have nothing but prime fruit. Now, I need to write the prime factorization. How do I write this as a prime factorization? Gabe?
2 times 2 times 2 times 2 times 3. Or 2 to the power of 4 times 3.
Good job. Oh, I missed one, didn't I? And that's something that sometimes, I heard you say it, Gabe, but I didn't write it, so I'm going to go 2 times 2 times 2 times 2 times 3. You see how I made sure that I had every one of them accounted for?
Yep.
Okay, so I've got 2 to the 4th times 3. Can I write it like that?
Yes.
Are either one of those acceptable?
Yes.
Do I have to write both?
No.
No. Well, can I check it to make sure, because this is really important.
Yeah.
Can I check it to make sure that this really is the number 48?
Yes.
How do I do that? How would I do it?
You can multiply 24 and 2 and 12.
Okay, I'm going to go back. When I check Bryson, I'm going to kind of make this where I know that that's my separate. And I'm going to go back to where I wrote that prime factorization. And I'm going to say 2 times 2 is
4.
4 times 2 is 8
8
times 2 is 16 times 3 is 48. And if I do that, I know I'm right. A while ago, I was missing a 2. If I hadn't caught it on my own, when I checked it, would I catch it?
Yes.
If I really check it, I would. Okay, if I really check it, I will. Okay? What is the greatest perfect square that is a factor of 1,575? Wow. That's ugly. You agree?
Yeah.
Well, let's just factor it. We're going to go and we're going to prime factor it. What's the first number that you know is gonna go into that? Is 2 gonna go into it?
No.
No. What's the first prime number that'll go into that? Ah, I said the first prime number, not any old prime number. What's the first prime number that's gonna go into that? Audrey? Aubrey? Yes. How do you know that, Aubrey? 3 definitely does. How do you know? Because you guessed? Huh? Ooh, what's the rules of divisibility for the 3s? What is the rules of divisibility for 3s, Melissa? The sum of the digits is divisible by 3. What's 5 plus 5? Plus 7? Plus 1 more? So is that number divisible by 3?
Yes.
It sure is, and that's where I start. Now, 3 goes into 15 5 times. 3 goes into 7 twice, and 3 will go, is that right?
Yes.
And then 3 goes into 15 another 5 times. Do we agree?
Yes.
Okay. It's not prime, so I'm going to keep going. What do I divide it by? What am I going to divide this one by? What do you think over there, Tylee? What's my first prime that'll go into this? Rules of divisibility. Brianna?
3.
3. Why?
Because all the digits add up.
And they add up to what?
12.
Good. And 12 is divisible by 3. So 3 goes into 5 once with 2 left over. 3 goes into 22 7 times with 1 left over. And 3 goes into 15 5 times. Do we agree?
Yes.
Okay? Is that number definitely is not prime. What's my prime number, the first prime that's going to go into 175? Isaiah?
3.
You say 3? If so, 7 plus 8, 1 is 8 plus 5 is?
14.
8 plus 5 is 14. That's not divisible by 3. That won't work.
8 plus 5 is 13.
8 plus 5, yeah, that's what I was thinking. 8 plus 5 is 13. It's still not divisible by 3. So that won't work. So what's the first one that will go into that? What's the first one there? Hang on a minute. Alexis.
First one,
Your hand was up. Come on, kid. You gotta already know it. What's the first prime number that'll go into 175?
15.
15 is not a prime number. What is the first prime number that's going to go into 175? Bryson, did you give up? Kinsey, 5. 5 goes into 17 3 times, leaving 2 behind. Do you agree?
Yes.
5 goes into 25 5 times. 5 is prime. What about the number 35? We're still factoring. 35 is divisible by what is the first prime that you think of there, Isaiah? 5. Good. 5 is my first prime. And 7, am I right?
Yep. 7. Yes. Yeah. Yeah.
So I got all my primes. I can write my prime factorization. And I'm going to write it as 3 times 3. Got this one and this one. Times 5 times 5. I got this one and this one. Times 7. Well, I know that equals 35, or equals 1,575. But have I answered my question? Nah, haven't, have I?
7.
Well, I'm looking here, though, and 3s, 5s, and 7s are factors of this number. Agree? The greatest perfect square that is a factor of 1,575. Well, I'm going to check with the 5. 5's got something to do with it, I would think. What do you think?
Yeah.
Got a calculator?
Yep.
I'm guessing. I'm taking a guess here. I'm gonna go with that 7 first though, and I don't know why, but I don't think it'll work. What's 7 times 7? 49? What's 49 times 7?
343.
Won't work, will it? It's not big enough, is it? What about the number 15? 3 and 5 together is 15.
110.
15 times 15 is 30 times 15 is...
15 times 15 is 45.
Oh, wait a minute, but it said square. I'm doing cubes. Well, that won't work. What was 15 times 15? It wasn't 30. What was it?
225.
Okay, we got to definitely go bigger. What about what's 525 squared? It's gonna be too small because it's times 3. That won't work.
1,575 times 3.
Oh, it says it's a factor of it though, doesn't it? What? What'd you say it was?
575 times 3.
No, I said square 525.
Oh. 15 times 31. Let's see, 15 times
25.
15
I do have it. I really do. Is this, look here guys, is that 15?
Yes.
Is that 15?
Yes.
And then what are all of those multiplied?
15 times 15 times 7 equals 1,500.
Okay, but what I'm saying is, when I found the prime factorization, I've got 3 times 5 times 3 times 5. Is that the same thing as 15 squared?
Yes.
Is 15 squared a factor of 1,575?
Yes.
Sure is.
Oh.
So, would it be my greatest factor squared?
Yes.
It is. Does that answer my question here?
Yes.
Right there. And I didn't see it and wouldn't see it without this, without doing the prime factorization. You see how we used it, and we did a guess and check here, but there is no other number squared bigger than 15 that's going to give you 1,575 as a factor. It's only one of its factors. Okay, not that it squared gave me 1,575, but that it, because I take 15's that's why it works, and that's why it's the answer. Does that make sense to you? Fist of 5, how much sense? Yeah, that's okay. Kind of a 3-4. That's okay. But if we hadn't used the prime factorization, we'd be here all day guessing and checking, wouldn't we? Yeah. Guess and check works, but I don't want to have to do it forever. Okay? I want you, on your paper, you have to write the prime factorization of 20. Everybody's doing number 5 by itself. Yeah, but I don't want it. I wanted it back. Yeah. Does that make sense? What kind of squared is that? are writing the prime factorization for the number 20 on your paper, you need to start. It doesn't say how you have to do it, does it? So you need to either list all, but it says prime though, doesn't it? So I gotta have my prime factor tree, don't I? Can I get the primes any other way? No. Gonna have to use that factor tree. Okay. I agree with you though. You gotta write the prime, you've got the tree, but that's not the prime factorization. Okay? Leave your tree there. Now write the prime factorization. Hey, I'm seeing kiddos with the right tree, but the prime factorization is the prime numbers written as the product of the prime numbers. So it's what kind of a statement? Product tells you what kind of a statement. What kind of statement? Multiplication. So I need to see the multiplication statement. That's the prime factorization. Yeah, that'll work. If you get that done, you may go ahead and do some of the others, but I'm going to come around. Yes. Only prime fruit. Only prime fruit. Okay, so what do you got to do with that one? Because is that prime? So you've got to have prime fruit all in the end before you write that prime factorization. You may do all of those in that box if you want to while you're waiting on somebody to get around to you. Okay, that's not written as a prime factorization. Remember yesterday, we talked about, remember even today, where's my prime factorization? Okay, so you gotta, but all you're doing is taking those down into a multiplication statement. That's okay, well you're not there. Let me see where you're at. Where's your prime factorization? I don't see the statement written. Yes. Okay, that's the tree, but that's not the prime factorization. Hey, if you don't know what prime factorization is, look at your vocab. Go look at the vocab. Remember we wrote an example? That's why we do the vocab. And if you look at that, you'll know exactly how to write that multiplication statement. Is that a prime number? So you're not done. Okay, look at your definition and tell me if you have written prime factorization. There's your sample of it right there. There's your example. Is that written? Yes. Is this written in this type of a form? I don't see prime factorization. I see prime factorization. Look at your definition, what a prime factorization looks like. You got the tree. And then what do you do with it? Right, they just have to be able to do one of them. Yes. All right, ladies and gentlemen, this is what I'm seeing. Everybody stop, look, I'm seeing all across the room. And I'm not the only one seeing it. I got 2 other adults that are seeing it. And we get like this, and we've got that, and we go here, and you got that, and you go, okay, there it is. There it is. And then I see people are moving on, and they're saying 2 and 44, I agree. 2 and, I saw one stop right there. But then I'm gonna go here. Now, are those all prime numbers?
Yes.
Yeah. But are those prime factorizations?
No.
Those are prime factor trees. But if you even look back up in your notes,
In your binder.
I love you, Lord. Look at the prime factorizations. This is the tree. This is the prime factorization. So when you get to that today, and you got to here, then you have to write it. That is the prime factorization for 20. Okay? I have to take it to this. This is my final answer. And on a test, that's what I would be looking for. Either that one or this one. And either one of those would be correct. Okay? So make sure you finish it out. Does that make sense to you?
Yes.
Okay, I'm going to move on over here to 462. Let's do that one. It's a big one. We're going to do it because what I'm trying to do is the next slide tells me what the assignment is, and I promised you 10 minutes because I owe you. So I'm trying to get there. All right? Are you guys good with that?
Yeah.
Fist to 5, where are you at right now with your level of understanding? Put it right here. It's not for the whole class to see. It's between you and me. All right, let's look at 462. Divisible by what is your first prime number you see? Instantly, everybody should see it. What do you see there, Caleb? 2, absolutely correct. Okay, and 2 goes into 4 twice, into 6 3 times, and into 2 once. 2 is prime. What's next? This is the way I organize it though, and I will always organize it this way when I teach it. Okay? It can't be 2, you're right, it can't, because it's not an even number. 3 and 1 is 4 and 2 is 6, so it could be what number? If the sum of the digits equals 6, what number? 3. Okay, 3 goes into 23 7 times, do we agree? With 2 left over, because 7 times 3 is 21. 2 left over, so is that 77?
Yeah.
Okay. What number is going to go into 77? 77.
11 and 7.
11 and 7, or 7 and 11, either way. I've got all my primes. Now, write the prime factorization on your paper. And show it to the neighbor. Good. Is it feeling, remember, go back, I need to look at something. Because I remember in the additional facts yesterday, what's the additional facts say?
Least greatest.
Make sure that you wrote it from least to greatest. That's that additional fact. So have you written? Here we go. 2 times 3 times
7 times 11
Equals 4.
Okay. Now I'm going to test it. 2 times 3 is 6 times 7 is 42 times 11.
462.
I just do 10 times 11 and then I do 2 times 3.
I went 2 times 3 and 6 times 11 and 6 times 2. 6 times 7 is 7.
I get 462 when I do it, so am I right?
Yeah.
All right. How does that feel? Are we good?
Yeah. I did a different one than that.
And
There's your assignment. It's small. Let's look at the textbook page 29. Let's do that first because those are the ones sometimes that cause you problems because they're reviews. Because you should have already done them, something like that, but textbook page 29.
Oh, yes.
Oh, 40 through 44 is subtraction.
Yay!
Okay, so that, well, don't say easy. I've seen your subtraction. Not yours, your specific, but I've seen